Hi, my name is Wu Lei. My student number is P142871. This is my presentation about the time series analysis assignment. First is about the case study 1. The first step, we can download the data and put into reviews. There are two variables. I called it cons and income. Cons is the real personal consumption expenditures. Income is the real disposable personal income. The next step is to do the time series plot. The time series plot of real personal consumption expenditures and real disposable personal income show that both series exhibit upward trend and seem to move together over the long run, suggesting potential co-integration. So we need to do the ADF test. Next step, conduct a unit root test on the cons state. There are three pictures from reviews. The results of the ADF test. Statistics are in the figure 6. The ADF test statistics above are more positive than that of the 10% critical values. So we fail to reject the null hypothesis of a unit root at the 10% significance level. The p-values also indicate strong evidence for to reject the unit root hypothesis. In conclusion, the cons appears to be non-stationary, so we need to do a unit root test on the first order difference of cons. There are also three pictures. They are from reviews, the results of the ADF test. The ADF test statistics of first difference of cons is in figure 10. The two of the ADF test statistics above are more negative than that of the 1% critical values. And one of the ADF test statistics is more negative than that of the 5% critical value. Then we reject the null hypothesis of a unit root at the 1% and 5% significance levels. The p-value also indicates strong evidence against the unit root hypothesis. In conclusion, the first order difference of cons appears to be stationary around a constant mean. Then we do the same steps for the income date. There are three pictures results of the unit root tests on the income date. There are statistics. The ADF test statistics above are more positive than that of 10% critical values. So we fail to reject the null hypothesis of a unit root at the 10% significance level. The p-values also indicate strong evidence for to reject the unit root hypothesis. In conclusion, the income appears to be non-stationary. So we need to do the unit root test on the first order difference of income. The pictures also from reviews. The ADF test statistics of the first order difference is here. And the two of the ADF test statistics above are more negative than that of the 1% critical values, and one of the ADF test statistics is more negative than that of the 10% critical value. Then we reject the null hypothesis of a unit root at the 1% and 10% significance levels. The p-value also indicates strong evidence against the unit root hypothesis. In conclusion, the first order difference of income appears to be stationary around a constant mean. So they are both I1. And next we do Johansson co-integration test. But before the test, we need to create a VAR model to conduct a Johansson co-integration test. The left picture is the result of the leg length critical. In the VAR model, we need to check the leg length. It is indicated by the asterisks next to the values for LR, F, PE, and AIC that the leg length criteria suggest an optimal leg of 6 for the VAR model. Next, we estimate the VAR again and conduct the Johansson configuration test. The left side also the results. And the trains and the maximal and eigenvalue tests you can see here and here indicate the number of cointegrating vector is 1 at the 0.05 level. The test statistics are greater than the critical values, reject the null hypothesis, and conclude that one cointegration is present. The fifth step is using FMOLS to estimate the long-run equation. The FMOLS results are shown in the left side. The FMOLS estimate suggests a strong positive long-run relationship between coins and income. You can see here. And with coefficients of 0.919424, the R-squared value is 0.994557, indicating that a dividend explains a large portion of the variation comes in the long run. The cointegration equation is below. The next an error correction model is estimated to capture the short-run dynamics and the speed of adjustment to deviations from the long-run equilibrium. This is the next one, the interpretation of the results. The ECM equation is here. Then we check the information. The adjustment coefficient is negative in minus 0.100434, and the p-value is 0.0005, which suggests statistical significance at the 1% level, confirming the presence of a long-run equilibrium relationship between real personal consumption expenditures and the real disposable personal income. The coefficient minus 0.100434 indicates that the coins adjust by around 10% per quarter to deviations for the long-run equilibrium. The coefficient of lagged difference of the variable income is 0.437259 and the p-value is 0, which suggests statistically significance at the 1% level, indicating short-run dynamics between the variables. From the regression results of the model, the real personal consumption expenditures is affected by real disposable personal income. If the personal consumption is necessary to be stimulated, it needs to consider how to increase personal income. Okay, next is about the presentation of exercise 1. Like before, there is the data and the variables picture. First, we downloaded the data and put into the eViews. There are two variables, EUUSD, which is the exchange rate for the euro against the US dollar. The second is the GBP/USD, the exchange rate for the British pound against the US dollar. We also put them into the picture and see the time series plot. The time series plot of the exchange rate for the euro against the US dollar and the exchange rate for the British pound against the US dollar shows that both series exhibit the same changes and seem to move together over the long run, suggesting potential cointegration. So we need to do the ADF test to check that. First, conduct a unit root test on the EUR-USD date. The three pictures was from eViews. The results of the ADF test showed in graph 6. The ADF test statistics above are more positive than that of the 10% critical values. So we fall to reject the long hypothesis of a unit root at the 10% significance level. The p-values also indicate strong evidence for to reject the unit root hypothesis. In conclusion, the EUR-USD appears to be non-stationary. So we need to conduct a unit root test on the first order difference of EUR-USD. The three pictures are the results of the test. The ADF test statistics are shown in graph 10. The ADF test statistics above are more negative than that of the 1% critical values. Then we reject the null hypothesis of the unit root at the 1% significance level. The p-value also indicates strong evidence against the unit root hypothesis. In conclusion, the first order difference of EUR-USD appears to be stationary from around a constant mean. Then we do the ADF test on the GBP/USD date. There are three pictures in the results from eViews. Then let's see the results of the ADF test statistics. The ADF test statistics above are more positive than that of 10% critical values, so we fall to reject the long hypothesis of a unit root at the 10% significance level. The p-values also indicate strong evidence for to reject the unit root hypothesis. In conclusion, the GBP/USD appears to be non-stationary. We need to conduct a unit root test on the first order difference of GBP/USD. The results from your eViews. There are statistics, and the ADF test statistics above are are more negative than that of the 1% critical values. Then we reject the null hypothesis of a unit root at the 1% significance level. The p-value also indicates strong evidence against the unit root hypothesis. In conclusion, the first order difference of GBP/USD appears to be stationary around a constant mean. The two variables are I1. Next, the angle Granger two-step cointegration test is conducted to test whether there is cointegration between EUR-USD and the GBP/USD. We need to using OLS to estimate the long-run equation between EUR-USD and the GBP/USD and save the residuals first. And the long-run equation of OLS is below from the picture left. We can see that there were a positive relationship between two variables. And conduct the ADF test on the residuals saved in step 5 here. To confirm cointegration, and from the results picture, we can see the p-value is 0.0127, and which indicating strong evidence against the unit root hypothesis. In conclusion, the residuals are stationary, so the two variables EUR-USD and the GBP/USD are cointegrated. Then estimate an error correction model using the saved residuals as the error correction term. And we can get the equation of ECM model. It's here. This is the result from eViews. And then this picture shows the results, interpretation, and implications for the foreign exchange market. The adjustment coefficient is negative in minus 0.003501, and the p-value is 0.0227, which suggests statistically significant at the 5% level, confirming the presence of a long-run equilibrium relationship between the exchange rate for the euro against the US dollar and the exchange rate for the British pound against the US dollar. The coefficient minus 0.003501 indicates that EUR/USD against by around 0.35% per day, two deviations from the long-run equilibrium. The coefficient of leg difference of the variable GBP/USD is 0.486745. The p-value is zero, which suggests statistically significance at the 1% level, indicating short-run dynamics between the variables. From the regression results of the model, it can be seen that exchange rate for the euro against the US dollar is affected by the exchange rate for the pound against the US dollar. Then EUR/USD can be predicted by using GBP/USD. That's all. This is my presentation. Thank you.